All right, so today we're going to start talking about constructing a graph from a table of information, and that information is going to depict change over time, and then we're going to talk about the pattern of change and how it's represented in a graph. So we are going to look at how a little bit of a story here. The story goes that Sydney, Cecilia, and Malcolm and Theo have heard about the great bicycle race Ragbri, and that they have decided to operate their own bicycle tour summer business and have chosen a route from Atlantic City, New Jersey to Colonial Williamsburg, Virginia. And they have named their summer business the Ocean Bike Tours. All right, so part of owning their own business is that they have to decide how far people can ride. They have to pick a route. They have to figure out where they're going to stop for the night, how long to make it, yada, yada, yada. Anyway, so they decide on a 3-day route. They figure that most people could probably ride 60 to 90 miles on a bicycle in a day. They find campground information. They plan rest stops and interesting information. But to finalize their business plans, they have to answer one more question. How are the cyclists' speed and distance likely to change throughout a day? So let's answer that question. Let's think about what kind of variables are associated with that question for a second. So what do you think? What are some things that might affect somebody's riding speed, or how far we could ride throughout the day? I'll give you some time. Okay, obviously, some things that might come up are things like hills. Okay, we've all been on a bicycle before. Going uphill is a little bit harder than going downhill. Okay, wind. If it's windy, if you're riding with the wind or against the wind, that's all going to play a part. Okay, the how well they can ride. Okay, kids versus adults, how old the riders are, how young the riders are. All of this is going to do how long they're riding, the speed at which you're riding. All of that is going to play a key, as well as many other things that I'm sure your list is a little bit longer than just these two things, as well as the ones that I didn't write down. All right, let's go on. All right, so getting away from the bicycle race for a second, in order to look at this whole concept of constructing a graph from a table of information that depicts change, we're gonna look at jumping jacks for a second. Of course, one of the variables was time, and the change that we're looking at is the number of jumping jacks that occurs as we increase the amount of time that we're doing these jumping jacks over. So I did some jumping jacks last night and did them for 70 seconds, had my son keep track, and started off pretty good here. Did 10 in the first 10 seconds. Of course, at 0 seconds, I had no jumping jacks, but did 10 in the first 10 seconds, did 10 in the first 20 seconds, then 30, and then I started to fall off over here. So we're going to just kind of transfer this information over onto our graph here. So we're going to label our axes first onto our graph. So just to remind you, we have an x-axis and a y-axis on our graph. This would be our x-axis in our table, and this is our y-axis. So let's come down here. We have time and total number of jumping jacks, and our time is increasing by 10 seconds. So we're going to go down here and label time in increments of 10. So 10, 20, 30, 40, 50, 60, and 70. All right. All right, so we're going to go back up here, and we're going to look at the scale for our x or our y-axis. Again, it's pretty close to every 10 as well, so we're gonna keep our label at 10 as well. So we'll label our y-axis according to a scale of 10. All right, so 10, 20, 30, 40, 50, 60, and one above it at 70. All right, and now we're going to plot some points. So we're going to do just like we were plotting ordered pairs, the X number and the Y number. Going to make these stand out a little bit more. All right, maybe not that much more. All right, so our first ordered is at 0, 0. So at 0, 0, got a nice big green dot right there. And then we had 10 and 10. And then we had 20, 20. And then we had a 30, 30. And we had 40 and 39. So I'm going to come up here and go in 40 seconds. I did 39. So that's a little bit below the line. And then 50 and 48. So in 50 seconds, I did 48. So that's going to be a little bit below the line. Okay. And then 60 seconds was 57. So again, below the line, a little bit further. And in 70 seconds was 65. So it's going to be about halfway between 65 and 70. Okay. And then I'm going to come up here, and because we're going to connect the dots, and how we can determine, because this is a dot plot, how we can determine if we want to connect the dots or not is if there is information that could be found between the points of information on our graph. Now, obviously, there is information between here, because if we kept time in increments of 5 seconds, we would have a number of jumping jacks for every 5 seconds. So we're going to connect the dots here, and we're going to look at the information. Now, there's a couple of questions. One, what does this trend tell you? This trend tells you that as time increased, so did the number of jumping jacks. What else does it tell you? It tells you that as time increased, the number of jumping jacks slowly started to, my rate of jumping jacks slowly started to decrease, which means that I started to get tired. So back to our original question, what do you think this means in relation to our bicycle group? Back to that original bicycle group, okay? How is this going to help our ocean bike tours? What do we think? How is the cyclist speed and distance likely going to change throughout the day?